Hi friends, today we'll start with fourth chapter part B. In this part we are dealing with prism. Now what is a prism? Check. Now this is your glass prism. So I will name this glass prism as X, Y and Z. Now this is called as angle of prism. This is the base of the prism. Now on this prism, this is my incident ray. Now but this incident ray is monochromatic light. Now what is mono? Is single. Chromatic is color. Single color light is incident on this part. Say this is PQ is my incident ray. Now I will write it is now going from denser to rarer. So this is the refracted ray and this will be the emergent ray. So I write QR is a refracted ray and RS is the emergent ray. Now over here I will draw normal. So this is the normal drawn to this part. This is the normal drawn to this part. So I will write this is the angle of incidence. This is what is the angle of refraction R1, R2. This is what is E. Now if this glass prism is not there, the path of incident ray will be something like this. If I take this emergent ray in backward direction, this angle is called now delta. Delta is the angle of deviation. Now this part is nothing but your say delta 1. This is nothing but your delta 2. Now can I say delta 1 is equal to, this is I minus R1, because this is I, so this is entire part will be I. Out of that, this is your R1, so remaining part will be I minus R1. Similarly, delta 2 is nothing but what? E minus R2. Now we have a relation based on this. You have A plus delta is equal to I plus E. Now you don't have derivation of this part. During our regular lecture, I will explain the entire derivation, but right now in this video it is not required. It is just a time consuming. So we'll get relation A plus delta is I plus E. Now from this we conclude that angle of deviation depends upon angle of incidence. So for that you have a graph. Now the nature of graph will be like this. This is angle of deviation on y-axis against the angle of incidence on x-axis. The nature of graph will be like this. The graph says that as you increase the angle of incidence, angle of deviation decreases, reaches minimum value and again it will increase. So this is the point where your delta is delta M and where your I is equal to what? E. So what is delta M is called as angle of minimum deviation. This is angle of what? Minimum deviation. So whatever is the graph, whatever is the diagram you have drawn is only applicable for angle of minimum deviation. So they can ask, draw neat label diagram when a monochromatic light is incident for on a glass prism for minimum deviation. So this diagram you have to draw. Now this delta is delta M, your I is equal to E. This is not given in textbook, so you should mark this part properly. Now I will substitute this part right here when your delta is delta M, your I is equal to E. So I will substitute these two values over here. So right here this is A plus delta M is what? I plus I. So right here therefore delta M is equal to 2I minus A. This is that relation, very important. Now on what factors delta depends? So I will write that part over here. Just check. So this is my delta is equal to, this is A mu minus 1. This is one relation. This relation proof is not there, not required for us. Now what is delta? Is angle of deviation. So angle of deviation depends on what factors? So it is directly proportional to what? Angle of prism. It is directly proportional to what? Refractive index. But your refractive index is inversely proportional to lambda. So right here delta is also inversely proportional to what? Lambda. Means if you consider that spectrum in that part, we'll study this in spectrum chapter. It is Vibgyor, VIBGYOR. There are 7 colors. This is the wavelength for violet, which is lambda 4, which is 4000 angstrom. This is lambda r, red color, that is 8000 angstrom. Now since your lambda r is greater than lambda v, so your delta v is greater than what? Delta r. So deviation is maximum for violet and minimum for red. Now this is for your second, this is there in your spectrum chapter. We'll discuss this part afterwards. Now